Hello and welcome back. This is part 2 of the preamp power supply upgrade, as it were. Need to cover a few things just before we crack on. Why didn't I just use an LM317? Because in theory it can provide 1 to 2.2 amps of current depending on the various type of LM317. The LM317 is protected. It has a few protection circuits built into it. Obviously this isn't an LM317, these are two tip 3055s. But heater, when you're supplying heaters, valve heaters, they're a difficult load because when you first switch on there's a big surge current, and so what I've had in the past is a problem whereby the LM317 either shuts down or goes into oscillation, which is not ideal. So hence the use of tip 3055 Z as a series pass regulating element. Ian kindly reminded me that a schematic might come in handy. So it's all pretty simple. This is a very simple regulated power supply. I'll just go through, I'll start here and then we'll work this way. So we've got a couple of windings, 6.3 volt AC windings. They're wired in series to give us what, about 12 volts ish AC. Blah blah blah, comes out there through a bridge rectifier, smoothed by this big 2200 microfarad cap. And we've got the LM317 680R 5k adjustable pot preset, and the usual sort of 220 resistor going from adjust to output. And then usually what you'd have on a proper regulated power supply, you'd have like another transistor here, something like a BD139, and then you'd have like your main series pass transistors, which is our two tip 3055s. As I'm trying to keep this all really simple, it's sort of pretty bare bones, and this is not an ideal way. This is not the best circuit that you can get. The other thing is that we're using 1R resistors, emitter resistors. They're there so that, as I mentioned previously, that the two tip 3055s, because they won't both have the same output current, so they're there to provide a little bit of negative feedback and sort of equalize things up a bit. These two 10R resistors, they're just there just to stop the two tip 3055s oscillating. The other thing that's missing off this is usually when you've got like a long distance from your 317 to your output, you usually have a few other capacitors just to make sure it doesn't oscillate, but like I say, it's pretty bare bones. Then the other part of the circuit is a crowbar, because I can't remember what I've got out here. Where are we? Let's see, we've got about 12 volts times 1.414 is about what, 18 volts, 20 volts something here. If any of this fails, we don't want 20 volts DC on our 6 CG7s. They're not going to be happy with that. So to protect that, we've just got a simple crowbar circuit, which is what this is here. What a crowbar circuit does is create a short with this triac. This is a C106D, something like that. So if the voltage here exceeds, I think it's about 7.2 volts, I can't remember what arrangement I've got here is, then this will fire the triac. Is it triac? No, it's a thyristor, isn't it? I always get the two buggers mixed up. SCR anyway. that will fire that, creating a short, and will blow the fuse which is back down here. I think I used a 6.2 volt Zener with another diode to give, like I say, about 7.2 volts, something like that. And you just got a capacitor here to stop the bugger oscillating. Same here with this 100R, that just sort of limits the current. Usually it would be a bit bigger, limiting the current going into the gate of the SCR, etc, etc. That one there, that resistor there, that's just there to limit the current going through the Zener. Hope that all makes sense. The other thing I didn't mention in the last video was that before I decided to go down this route of all this McGubbins, I did think of putting fans in, so I got this little fan here, but it's really not the provision on the power transformer for another fan, and it's noisy. I did have this little 5 volt laptop fan with a big copper plate on it, but somebody who shall remain nameless put 12 volts in it and that died a death, and it wouldn't have fitted anyway. I also went through a whole load of heat sinks that I've accumulated over the years to see about using one of them. Again, we're limited with space, etc. Really, the 2-tip 3055s would, you know, benefited for something like this. It's not the room, and it's not the way to really mount it. To bring us up to date, I fettled the 2 micropads. I thought it would have been difficult to drill, but actually it was not too bad at all. So they will go underneath the 2-tip 3055s. There's a banging down the bottom there that will insulate the leads from shorting out there, and then it's just a matter of securing it to the back of the preamp chassis. Yeah, and that will go on top as well, just to provide a bit more cooling. So that's the whole shebangle in there. Heat shrink, not heat shrink, what the fuck is it called? That gunk. Thermal, what the hell is it called? Thermal heatsink paste everywhere. And then next, I hope that I've got all my measurements right. Oh, now then. Oh, are those bloody screws gonna be long enough? Of course you can't see, can you? Right, I need to just have a look off camera and see what the crack is. I'm ready to put the heatsink on top of the tip 3055s. This is a 3mm nut, and it won't go into the vanes of this heatsink. So just to keep things interesting and to keep me on my toes, we've got to try and modify that. And this involves the use of an angle grinder, pyramid grips, and a bit of fettling. And as you can see, that goes in. I just hope there's some structural, there's enough metal on the nut so that, you know, it don't fall apart. What I'm going to do, I'm going to super glue that in place so that I don't have to so it makes fitting easier. Here we are sometime later. That's in there now. I've had to do a bit of fettling and whatnot to get it to fit, but that seems to be all secure. I can't see what's going off underneath here. It's not wired in. It's not wired in or anything yet, so I need to check if we've got any shorts. So this is collector. Oh, helps if you turn the bloody. This is collector. Both collectors. No, we've got no short there. So this is, where are we? Collector to emitter. No short there. And this is collector to bases. Okay, we're on wobble cam to try and get everything in. The power supply is connected to my Variac lamp limiter, and that's the meter there. Everything's secure, seems to have gone in okay. Few wires all over the shop, but I'm trying to get this filmed because my daughter's after nicking the camera.
Whoa, what do you mean by that?
To go to a party, so I'm afraid I couldn't do this as... Can you hear her? I don't know if you can hear her squawking in the background there. There we go. 240 volts AC. It's a little bit low, but nothing's gone bang, nothing's smoking, so we're all good. We're all golden, as they say. So obviously there's a bit of tidying up to do and what have you, and obviously I need to then test it with the actual preamplifier and see if it cures the problem of it getting too hot. So that about wraps it up. As I said, I would like to have done a bit more complete a video, but my daughter's over to a party tonight in the next village over, and she wants to borrow the camera to capture all the party goodness. In the next video, got a nice little treat for you. Got a couple of these Citron Electronic Corporation Citron C805. These are 805 power triodes that somebody kindly gave me some time ago. If you can see there, seems to been like the top cap stuck on with epoxy. Bit of a mucky job, bit of oxidation going off there. But yes, in the next video we'll get back to Velvy goodness and we will test a couple of these 805 power triode valves, and then at some point in the future I intend to make a amplifier with these. So thank you all very much for watching. Take care of yourselves. Ta-ra for now.